Good afternoon, my YouTube viewers. It's Crystal here. I just wanted to make a quick code review for you, and it's going to have to be a quick one because I didn't have any internet on my phone, and basically what I do is I tether my tablet and my laptop to my phone to get internet that way. I don't have broadband or anything like that, and I couldn't get the internet to work for about an hour and a half at least. I don't know how long exactly it was down, and I was really upset. You know, technology is a wonderful thing until it doesn't work. And then when it doesn't work, then we've got all kinds of problems. And so I'm actually tethering off of my boyfriend's tablet at the moment to make this video. But I do think that my internet's working because I've got it on my tablet and my phone. But that just shows you how fragile our society is, that we need technology so bad, which is a good thing that I'm making this code review, because this code review is to do with machine learning. And even if you decide that you're not going to do machine learning, you're going to do something else in technology, it's a very good stepping stone. So what we're going to do is we're going to use the CTG dataset and do random forest on it. And it is an interview question. I got this interview question, and so this is an interview question. So you should be asked it on an interview. So let's just see what CTG dataset is. You can see I've been phoning Vodafone, or trying to phone Vodafone to ask them what the problem was. I wasn't very successful. The CTG dataset is a cardiotocography. It consists of measurements of fetal heart rate and uterine contraction features on cardiotograms classified by expert pediatricians. So this is something to do with when a lady goes into labor. And so the thing is I didn't know what CTG was. And the thing about being a data scientist, when you're working for a company or you're working for a project, you have to know what the project is all about. And that's why data scientists get paid so much money. They get paid so much money because they have to know everything. It's not enough to say, oh, well, I don't know what it's all about, I'm just doing the calculations. You have to actually know what a CTG is, which I didn't know that, so I had to look it up. And the data scientists get paid a lot of money because they have to know what's going on with the industry that they're working in. So we know what a CTG is. It's a piece of, it monitors fetal heart rate and uterine contractions. So it's something to do in the medical field, in the maternity field. And then so I created this program on Google Colab, which is a free online Jupyter notebook. And it's a great platform to use to write programs in Python because it's free, and it's online. But the problem is it doesn't have a good undo function. So if you accidentally overwrite or delete code, then you're going to be stuck because you won't get it back. You might be able to go into the site history and then go into the site history and you may be able to retrieve the file, but it's no guarantee. And then so after we've created our Jupyter notebook, we're going to import our libraries. And the way you're supposed to do it is you're supposed to import all the libraries at the very beginning of the program. And since this is an interview question, I decided that I would do it the way you're supposed to do it. So we've got all the libraries imported at the beginning of the program. So we're going to import pandas, which takes your data frame, takes your data set and converts it to a data frame, and it also processes the data. We're going to take NumPy, which creates NumPy arrays and does numerical computations. We're going to import sklearn, which gives you your machine learning functionality. We're going to import matplotlib that visualizes your data, and we're going to import seaborn, which also visualizes your data statistically. So after we have imported the libraries, then what we're going to do is we're going to load the data set. So we want to set it up so that we can see all of the columns. So in order to set it up to see all of the columns, you do pd.setOptions display.maxColumns none. And then to read the data set in, do df equals pd.readcsv, and then the link to the data set. And I got the data set from someone's GitHub account. And then you got df. And then this is your data frame, which is 26 rows by 23 columns. You have 23 columns of data. NSP is your dependent variable, and the rest of the columns of data are your independent variables, because that's the interview question is to actually do a random forest classification on the CTG data set and use NSP as your dependent variable and all the others as the independent variable. So now what we're going to do is we're going to analyze the data set. So we have 3 unique values in NSP. So that means it's 3 classes. You've got a multiple class target or dependent variable. And then what we're going to do is we're going to check all of what type of columns you have. And fortunately, all of the columns are either numeric or float. So that's good. That's good. So you don't have anything to encode. And now we're going to define our target. Your target is NSP. So you have df.pop NSP, and so what that does is that just pops NSP out, and so you don't have to worry about that anymore. And then so we're going to analyze the target with seaborn sns.dispplot target KDE equals true. So you can see number 1 is the most numbers, number 2 is the middle numbers, and then number 3 is the least numbers. And one thing that I could have done was I could have said this. So let's try this. Hopefully I did it right. So yeah, so I did it right. And so 1 is 1,655, 2 is 295, and 3 is 176. So that tells you how many examples you have of each class. And then what we're going to do is we're going to create a heat map from the data frame. So this is your heat map from the data frame. So you see over here we have a few columns of data that are very high correlation. So I went and did the core, and when I did the core, I went and found the high correlation, but it was 93. It was a high correlation, but it was 93, and it wasn't 95, because generally what happens when you get rid of the columns of data that are highly correlated, generally what you look for is over 95. So this is 0.948, so it's not quite 95, but that's what you want to do. You want to remove the columns of data that are over 95 because they're highly correlated and then they cause redundancy. But what you have to do is you have to run it up without the highly correlated columns removed and see what your accuracy is, and then run it up with the highly correlated columns removed and see what your accuracy is, and then select the method that gives you the greatest accuracy, because that's one thing that you're always supposed to do. You're always supposed to like test it. You're supposed to find out, is it better with removing the highly correlated columns, or is it better without removing the highly correlated columns? So it does take a lot of work and a lot of time to get a data set correct, but because we had one that was very nearly 95, but not quite, I didn't remove the columns of data that were highly correlated, and there's no guarantee that would improve your accuracy, because you have to check the accuracy when you remove it and then check the accuracy when you don't remove it. And then so we're going to define our dependent and our independent variables. But before I do that, I would like to say that I didn't standardize the data. And the reason why I didn't standardize the data is because on random forest, you don't have to standardize the data. So usually whenever you're doing machine learning, the data is going to be standardized. But because we're working on a random forest, it's not necessary to standardize it. But if you want to, you can standardize it and see what your accuracy is, and then don't standardize it and see what your accuracy is. And then so now after we haven't standardized our data, we're going to define the dependent and independent variables. So your y is your target, which is your dependent variable, and your x is your independent variable, which is your data set. And now we're going to use train test split from sklearn to split the x and y variables up into training and validation sets. And the test set is going to be 20%. So the train set is 80% and the test set is 20%. And you always want to check the shape of the file so you know what you're dealing with. And now what we're going to do is we're going to work on sklearn's random forest. We're going to use a random forest classifier. Max step equals none, random state equals 42, and then we're going to fit it into x train, y train. We're going to print the score, the accuracy of x train, y train, and then you got 100%. And now we're going to predict on the validation set. So ypred equals clf.predict xval. And so here's your predictions, because I always like to look at the predictions, see what I've got if I can. Now we're going to check the accuracy. Again, this is with sklearn. Accuracy score is yval, ypred. You have an accuracy of 97%, which is not too bad on a validation set. Now we're going to check log loss, and what log loss is log loss is type of error, and what it does is it compares the actual values to the predicted values, and then it gives you a number, and the best number is 0. So we've got a number of 0.08, so that's a very good number on your log loss, and it's type of an error message, an error figure for classification models. We're going to create a confusion matrix. Confusion matrix tells you how many examples you've got right of each class and how many you got wrong. So over here on the first confusion matrix, which is 1, you got 331 right and 2 wrong. And on 2, you got 58 right and 6 wrong. And 3, you've got 28 right and 1 wrong. So that's your confusion matrix. And it just tells you how many you got right in a class and how many you got wrong in a class. And then what we do is after we've done our created our confusion matrix, we're also going to print a classification report, and that gives you more details. It prints off your precision, recall, F1 score, and then it's your supporting examples. So that's it. So that's it for this interview questions, which it asks you to create a random forest classifier on the CTG dataset, and I've used sklearn to do that. And so I would study this. You've got the code, and I would study this and practice it, because if you're going to go on an interview, they very well could ask you that interview question. They're definitely, if it's a job for machine learning, they're definitely going to ask you some machine learning questions. So I definitely would study that. So I'm going to go ahead and conclude this video. So I'd like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more videos for you in the future.